Dr. V. Jayalakshmi is working as a professor in the Department of ECE, Anna University, Chennai. She has more than 17 years of experience in teaching. She has published more than 90 papers in international and national journals and conferences. She has organized more than 10 workshops and has attended more than 40 workshops and seminars. She has guided more than 100 projects in both UG and PG level. She is supervising 14 research scholars. She has established an AICTE sponsored MODROB project for VLSI Lab. She has an endowment award for the top rank holder in PG degree and has 4 cash awards for producing cent percentage of result in Anna University curriculum. She is a life member in various professional bodies like ISTE and IETE. She has specialized in mobile communication, microprocessor and microcontroller, digital system, computer networking, and neural networks.
Welcome to UGC lecture series, BSc Electronics Harness, Electronics Practicals 9. In this episode, we will discuss how to add to 16-bit numbers with carry and without carry. So, I will start to write the program of 16-bit data. 16-bit data is 7829, then 4257. Okay. So, now I add the number 9 plus 7 is 6, that is 16. So, automatically 1 0. So, I will write 0 here, 1 will carry. So, this number is 8. 8 plus 2 is A. 7 plus 4 is 11, 11 equivalent is BA. So, this is a 16-bit, right. Now, first I will write the program using 8-bit registers, right. So, how to write this? So, I will separate this for simply I will use to load the 16-bit data LXI B comma the first data which is 7829, then LXI H register pair 4257, right. So, after that now I want to add 29 and 57, right. So, one of the data should be moved to accumulator. So, I will move, this represents indirectly BC register, right. This is a BC register, this is a HL register, this 78 in B, 29 in C, 42 in H, 57 in L register, right. Now, I call the C value to accumulator A comma C. So, the 29 is moved to accumulator which should be added with L register. So, I simply use add L. So, what is the meaning of that? The L value 57 is added with the 29. Now, the result is stored in the accumulator, that is A resultant value is A plus L, that is 29 plus 57, right. So, before moving into addition of higher byte, I have to store the result in any one of the register, because the another also should be done with the accumulator. So, I temporarily stored in the unused register which is move D comma A, right. Now, I have to add the 78 with 42, the 78 which is B register, 42 in the L register. So, I will move accumulator comma B register, then add H. So, now the accumulator have accumulator plus H value, or it is nothing but B plus H, right. Here C plus L. So, the value was 78 plus 42. So, the resultant is stored in the accumulator, right. So, the addition is over. Now, we have to store the result. One result in this accumulator, another result in the D register. Suppose I have selected the location to store the resultant value as 4500. So, 4500 means the lower byte 80 will be loaded. Then 4501, the higher byte which is BA will be loaded. Now, I have the higher byte which is to be loaded in 4501. So, I can use it STA 4501, right. Then the next data I could not store directly. So, I have to move the data to accumulator. This is a lower byte value, right. This is a lower byte resultant value, which is 80 in the D register. Now, I am moving D to accumulator, that should be loaded in 4500. So, I use STA 4500, then I stop the program. I simply loaded the two 16-bit data, then the lower bytes are moved. I have first added the lower byte, then higher byte. So, for that one of the data should be loaded in accumulator. C data, which is 29, is moved to accumulator, the 57 is added directly. So, the another higher byte also performed with the accumulator. So, before that the accumulator content is temporarily stored in the D register. Now, the higher bytes 78 and 42 is added. So, the 78 which is in B register is moved to accumulator, 42 is directly added. So, the higher byte is stored in the 4501 address, the lower byte is moved to accumulator, then stored in 4500, then stop the program. This is a one way, right. This is the first example. Now, we will do the second example. In the second example, I have taken the two different 16-bit number, one is 7894, another one is 3383. So, now add it, 4 plus 3 is 7, 9 plus 8 is 17, right. So, 17 we have to convert into the hexadecimal. So, 1 1. So, I will write 1 here, the 1 is carry over from lower byte to higher byte. So, now 8 plus 3 is 11, 11 plus 1 is 12, the equivalent is C. 7 plus 3 is 10, we have to write it as AC, right. So, whether the same program will suitable for this example, we have to check it, because we are adding only two numbers, right. Here in the lower byte carry, how to carry for the higher byte. So, just change a single line in this your program, instead of using ADDH, you use it ADCH. If you are using ADCH, what it will do, that is the B value is added with H value, plus if any carry is occurred, that also included. So, by changing the simple program, if any carry is occurred in the lower byte, it automatically carry over to the higher byte. So, this program shows the addition of two 16-bit number. So, the first I have started with two 16-bit number, there is no carry between lower byte to higher byte. If suppose carry occurred from lower byte to higher byte, only the second add instruction is replaced with the ADC, because here only we are including the carry, no need for including ADC for lower bytes. The carry never occur in the lower byte, only in the higher byte, that is why we are replacing ADC. While executing this program, we will check it how it will run. Now, I will explain how the same program will replaced by using the 16-bit addition instruction. What is the name of that? DAD instruction, right. So, first as usual we have to initialize these two instruction, LXA B, 7829, then LXA H, 4257. So, after that, instead of using these kind of instructions, okay, just I am writing DAD, DAD B. DAD B represents the BC register pair is added with HL register pair, then the result is stored in HL register pair. Now, result in the HL register pair. So, with the help of SHLD instruction 4500, I can store the resultant value. So, only 5 lines, LXI H, 4257, LXI B, 7829. Okay, LXA B, 7829, the first 16-bit data, LXA H, 4257, second 16-bit data. By using add instruction, the 16-bit content of BC is added with the HL register pair content. Finally, the result is stored in the HL register pair. So, from the HL register pair, we have a separate instruction how to store it. So, automatically what it will load, the L value will be loaded in 4500, then the H value will be loaded in 4501. So, this is the way we are accessing to store the 16 bit. Now, how many addresses required for writing this program? So, for this instruction 3 addresses need, this is 3, this is 1, this is 3, this is 1. So, totally 11 addresses required. In this program how many addresses required? 3, 3, then 1, 1, 1, 1, 1, 3, 1, 3, 1. So, how many instructions required? 4, 8, 10, 13, 19 address. Here 11 address only required, here 19 address. So, automatically it indicates it will take more time to execute the program, here only less time to execute the program. Now, we will execute the first 16 bit addition example, which is 78, 29, 42, 57. So, I will select the address 4100 to type the program. So, in 4500 I will write the first opcode for LXI B 01, then the input first lower byte, then higher byte, then LXI H 21, then lower byte of second data, higher byte of second data. Then the lower byte is moved to accumulator 79, then 85 is add L, then temporarily store the result in D register, opcode is 57, then move A comma B, higher byte is moved to accumulator 78, then add H 84. So, after addition we have to store the result STA 32 01 45, then move the lower byte D to accumulator, opcode is 7A 32 0 45, then 76, then clear to address. So, before executing take the program and check it. So, this is the LXI first data, LXI H comma second data, then first data 79, 85, 57, 78, 84, 32, 01, 45, 79, 32, 0, 45, 76. So, reset, go, starting address 4100, execute. So, now program is executed, reset, take the resultant address which is 4500. So, what is the answer of this? 78 29 plus 42 57. So, the answer is BA 80. So, first it will show the lower order address 80, then higher order BA. Okay. So, this is the correct answer which already we have discussed. So, now I will give the another input in the same program, whether it will work or not I will check it. So, take 4100. So, first data 01, I will give 78 94. So, first I have to give the input as 94, then 78. Another data is LXI H 21 comma 83, lower data, higher data is 33. So, already we have discussed, right. The same program I am executing, my expected answer is AC 17. So, execute 4100, reset, take the address 4500, address is, what is the result? AB 17 it comes, actual answer is AC 17. So, what is the error in this? The lower byte carry is not included in the higher byte, right. So, what we have to change in the program, instead of using ADDH in the program, we have to use ADCH. ADCH is addition with carry. If any carry is there, it will be carry over to the higher byte. So, I will change the corresponding opcode which is 84, which is already written. So, now the 84 is replaced with 8C, 84 is opcode for add H, 8C is the opcode for ADC H. So, now I have changed the same program with addition with carry. Now, execute the program, go 4100, execute, reset, sub the resultant address which is 4500. So, expected answer is AC17, right. So, first lower byte 17, then higher byte 8C. So, this is a program which is 16-bit addition with carry. Addition with carry means the carry in the lower byte carry over to higher byte. Same 16-bit addition program is replaced with the DAD H. So, this is 16-bit addition. Now, we will go through how to add 16-bit addition with the carry. Suppose I am taking two 16-bit numbers 78, 29, here A 3, 4, 3, right. This is my 16-bit number. So, this is the first data, this is the second data. So, how to add? So, 9 plus 3 is 12, 12 equivalent is C, 4 plus 2 is 6, 8 plus 3 is 11, its equivalent is B. A is 10, 10 plus 7 is 17, so its hexa equivalent is 1 1, right. So, 17 should be converted into hexadecimal, then only you have to write it. So, the HL register pair size is only 16 bit, right. So, in that the 6C will be loaded in L register, 1B is loaded in the H register. What about this additional 1? This is a carry. So, this is exceeding the size, right. So, if carry is occurred, we have to check and initialize the separate register to hold the carry. Now, I will start to write the program. For 16-bit addition, one of the data must be loaded in HL register pair. So, in the HL register pair, I will store the first data. In the second one, I will store any register. I will select the D register LXA D comma A343 H. Now, I am using the DAD instruction. So, DAD D, it represents the DE register pair is added with HL register pair, the result is stored in the HL register pair, that is E and L is added, stored in L, H and D is added, the result is stored in H. If any carry from lower byte to higher byte, it automatically include and carry over in the H. So, after addition, now I have to check whether the carry flag is set or not. If no carry, simply use SHLD 4500 to store the result. If any carry is occur, then we have to initialize one more register which is unused register MVI B comma 00H, right. DE register pair already used, HL register pair is used. So, only B and C is remaining and accumulator also remaining. You can use any one of the register. If carry is occur, then what I have to do? INR B. So, INR B means if carry occur, this instruction will execute. If no carry, it directly switch over to this instruction and execute it. Now, I have to add few more instructions because I have to store this address also. So, move A comma B, then STA, because accumulator value stored only via STA instruction, STA 4000. Here how many addresses required? This is 3 byte instruction, right. So, in this suppose I am taking 4500, in 4500 6C will be loaded, 4501 1B will be loaded, the higher byte should be loaded in 4502. So, 3 addresses needed to store the resultant. So, by using SHLD instruction, L and H value will be loaded in 500 and 501. Now, I have to use 502 for storing the carry value, then halt it. So, this is a program to store the 16-bit data with the carry. Now, we will execute the same program in the kit. I think you know how to convert this program into opcode. So, I will show the opcode in the kit. So, I will take the input 78, 29, 42, 57. So, I will type the program in 4100, that is 16-bit addition with DAD instruction. So, first LXI B 01, then lower byte data 29, higher byte data 78. Then next LXI H comma 42 57. So, 21, first lower byte data 57, then 42. Then we have to use DAD B, which is 09. Then store the result SHLD 4500, which is 22 0 45. Then stop the program. So, now execute, go 4100, reset, take the resultant address 4500, answer is BA 80, right. So, the lower byte in the lower address 80, the next higher byte which is BA in the next address 4501. So, in using the DAD H, if you have with carry, the last example. So, in the last example, during the addition of higher byte we have to use ADC, right. So, in the DAD instruction, no need of that, the carry automatically include. So, I will give in the same example 94, 78, 83, 33. Sub 4100, 01, 94, 78. After that we have to give 21, 83, 83, 33. Then add DAD B, store the result. So, once again I will check the program 4100, 01, 94, 78, then 21, 83, 33, add OK. Now, go 4100, execute, reset, sub 4500. So, the resultant is AC 17. So, first it will show the lower byte 17, then AC. Now, we will execute while adding two 16-bit number if carry is occurred, that is it exceeding the size. So, we have to initiate one more register to hold the carry, right. So, now we will execute that program, that is summation of 7829 with A343. So, I will take the same address 4100 to execute the program. So, while typing this, the 4100 will be loaded in the program counter. So, while giving go starting address, it automatically read or fetch the instruction from the program and execute continuously till reading the 76, that is halt instruction. So, I will give first data in HL register pair 21, 29, 78. Then next register 11, 43, A3. Next the register accumulator is initialized, that is one of the register B register is initialized to hold the carry. Then DAD 19, then store the, if any carry is occurred, D2 to the next address I will leave some address, then 41, then 04 for increase, then store the result 00, 22 0, 45, then 78, that is moving that higher byte carry in that register to accumulator, then store via the STA instruction in the higher address 4502, 76. So, before executing, check the program once again. So, 21, 29, 78 is LXIH, then LXID is 11, 43, A3, then 060, 19. In D2, I have to give SHLD instruction, right, where the 22 410D. So here 0D, the next address is 41 19 D2 0D 41, then 04 22 0 45 78 32 02 45 76, then clear the address. Now we will execute the program. Go 4100, execute, reset, take the resultant address 4500. So what is our expected result? 6C 1B01, right. So 3 address we have to read, because 16-bit data with the carry, so 24-bit it generate the result. So the result is 6C 1B01. 7829 added with A343, the result is 11B6C, but here we are reading from lower byte, higher byte, lower byte 6C, higher byte 1B, then carry is 01. Okay. So this is the way we are executing the 16-bit addition program with the carry, or same thing with using the DAD instruction, and if any overflow is occur, how to initialize one more register to hold the carry. In this episode we have discussed about how to add two 16-bit number with carry and without carry. With the help of add and ADC instruction we have done the addition. The same program is replaced with the DAD instruction. The DAD instruction which is used to perform the 16-bit addition directly with the help of HL register pair. Questions: what is the need of ADC instruction in 8085? How the DAD instruction will execute in 8085? Why the accumulator is used for addition? Write a program to add 35H, 67 and 56 hexadecimal numbers. Thank you.